Listen here, all of you. Okay, today we are going to discuss about the Maxwell's equations. Okay, the Maxwell's has created the four different equations for the magnetic field. So that is the first equations. That is the Maxwell's equation from the Ampere's law. So you all know the Ampere's law. The Ampere's law states that the magnetic field intensity around the closed path of the line integral, it should be equal to the direct current. Okay, so the magnetic field intensity, the line integral of magnetic field intensity around a closed path is equal to the current or direct current or total current. So we need to convert the total current in terms of current density. So the total current, in the sense it has been included both conduction current and as well as the displacement current. The conduction current, it is related to the resistance medium like conductor. So the displacement current, in the sense it is related to the capacitance. So the current density, while you are writing the total current in terms of current density, that is the J. Okay, the surface integral of, because the current density, while you are considering the current density, it has been considered the total area. Normally the density means density, it should be equal to the total medium. If you are finding the total current density, that is the total current I divided by the total area. Okay, that is the actual formula. Normally the current density, it should be equal, or current density D, if you are considered as the J is the current density, J it should be equal to I by A, the total current or total flow of current in the conductor divided by the area. That is the actual formula for the current density. So while we are writing the current density, that is the J, it should be equal to I divided by A, it will come. That is why we are added the surface integral. But here the total current is the conduction current as well as the displacement current, both are included. So first you need to find the conduction current or conduction current density, because here we consider the current density in terms of current density. So while you are considering the current, that is the conduction current and displacement current, so you can you need to find the current density of the each case. So that you can find the conduction current IC. From that you can find the conduction current density. Okay, the IC, it should be equal to, from the Ohm's law, the V equal to I into R. So the IC, why the IC is came? Because the C is indication of conduction current, conduction. Okay, so I is the current, C is the conduction. Okay, IC, it should be equal to V by R from the Ohm's law. So the resistance, we know the formula, R, it should be equal to rho L by A. The rho is the resistivity of the element, L is the length of the conductor, and A is the total area of the conductor. So in terms of, if you must know the relationship between the conductivity and the resistivity. So the sigma is the conductivity, the 1 by rho, that is the resistivity. Okay, so the reciprocal of resistivity, that is the conductivity, or reciprocal of conductivity, that is the resistivity. You can consider like that. So you can, because here we are considering the conduction, so we need to consider the conductivity. Okay, from the resistivity you can convert again the conductivity, that is the R, it should be equal to L divided by sigma into A. So the sigma is the conductivity and the area of the total area of the conductor, length of the conductor. So this R value you can substitute in the equation, that is the previous expression, V divided by R. So the L by sigma into A, it may come. So here the V divided by V into, because the last denominator, so already we have the formula V into sigma into A, that is the sigma A is the last denominator, can multiply it with first numerator, V into sigma A divided by L. So we know the electric field relationship, potential, it should be equal to the electric field into the length of the conductor. Here we are consider the length of the conductor, because the conduction current we have considered the conductor. So the conductor, it have the specific length like this L. Okay, suppose if we are consider the capacitance, so the distance between the parallel plate, that is the D. So the potential, electric potential, it should be equal to E into distance will come. The distance may be the length or distance between the plate. That is the relationship between the electric potential and the electric field. V, it should be equal to E into L, because here we are used the notation L. So here also we consider V, it should be equal E into L. That we can substitute in the previous expression. So the both the L, it may getting cancelled. So the remaining value E into sigma into A. So IC divided by A, that is the I by A, you know the current density, right? So IC by A, again JC, that is the conduction current density, that is the sigma into A or sigma into E or E into sigma. Okay, from this expression we obtained the conduction current density. Okay, so similarly you need to find another one current element, that is the current density through the or due to the displacement current. So the displacement current, you can consider the capacitance. So the displacement current, it should be equal the rate of change of charge with respect to the time, right? That is the capacitance. The charge, it should be equal to C into V. We already derived the expression also. So the Q, it should be equal to CV. In the third unit, sorry, second unit, we derived the expression for the last while you are finding the capacitance in the two medium or two parallel plates. So you may consider the Q should be equal to C into V. So you can substitute the Q, it should be equal to C into V. So here the C is the total capacitance, it will never vary. It is also depends on the potential difference. So again we can ID you can constant value, that is the key C value, you can kept it constant, and dV by rate of change of potential with respect to the time. The ID becomes C into dV by dt. So the C value, that is the capacitance in the medium, it should be equal to epsilon into A divided by D. Whereas epsilon is the permittivity of the medium, A is the area of the total area of the capacitance, distance between the plates, right? That is the capacitance. So you can substitute the C expression in the previous equation. ID, it should be equal to epsilon A divided by D, dV by dt. But we all know the relationship between the V and E. So that is why V, it should be equal to E into D. You see, you have to remember the V equal to, that is the electric potential, the relationship between the electric potential and the electric field. The V, it should be equal to E into D, here we are written, but in the previous case, V, it should be equal to E into L, because in earlier we considered the length was, the notation was L. Okay, the distance was L, length of the conductor, that is the L. Here we are considered for the capacitance, so it's have the D. Already here we are written the D. So the V, it should be equal to E into D, it will come here. Okay, so you can substitute V equal to E into D. So here already V in the differential form, the distance never it will get changed. So you can kept in the constant. So you can write like that. The dV in the case of dV, you can write dE by dt. Again the d and d it may getting cancelled. Then epsilon A into dE by dt. Okay, that is the differential term. So again here we are considered only for the electric field. Okay, change in electric field can produce the magnetic field, right? So here the electric field alone we consider. So we are rearranging the equation. The A we are moved from LHS side to RHS side. ID by A, we have obtained the current density. So ID by A, the epsilon into rho E, dou E by dou T, that is the partial. Again these both are the same. So for our convenience, in the many cases we consider for the partial differential equation. So we can convert like that, dou E by dou T. So here we know the relationship between the electric field intensity and the electric flux density, right? So E and D. So epsilon D, it should be equal to epsilon E. You know the relationship. So through that we are converted from this relationship. We can convert dou D by dou T. So that is the JD, it should be equal to dou D by dou T. Okay, we obtained the both the current density, that is the displacement current density, and the conduction current density here. So the total current density becomes the sum of conduction current density plus displacement current density. So we already written the expression, line integral of h into dl, it should be equal to the surface integral of j into ds. Instead of j, you can replace the jc plus jd, right? So you can replace it. Then the corresponding JE value, that is the JC value, sigma into E, that we obtained there. JD, that is the current density, displacement current density, that also we obtained here. That you can write it instead of J, you can replace. Just you can JC instead of JC, you can replace it. JD, you can replace it. Here as it is, the surface integral, you keep the same. So here the line integral of h into dl, right? So you can apply the Stokes theorem. From the Stokes theorem, h into dl, it should be equal the surface integral of del cross h into ds. Then you can substitute in the case of, just you can replace the h into dl into surface integral of del cross h into ds. You can consider the both the side the integral was same, right? Both the side the surface integral was there, so you can eliminate it. So finally you can obtain del cross h, it should be equal to sigma into E plus dou d by dou t. Otherwise, if you are here, it is the electric field. If you are written here also in terms of electric field, what it will come? Epsilon into E, right? If you are one term is the electric field, it is the electric field related. Here the E is there. If you are writing here also in the E term, epsilon into dou E by dou t will come. Okay. Suppose if you are written both are the magnetic field, both are in terms of electric flux density D. So you know the relationship. According to this, you can convert and write. Okay. The del cross H it should be equal sigma into E plus epsilon into dou E by dou t. That was the expression for the Maxwell's equations from the Ampere's law. Okay. So you should remember two things here. You have to consider for the total current. In the total current, it's have the conduction current and displacement current, right? The conduction current, from the conduction current, you need to find the conduction current density JC, right? In the displacement current, you can find the JD, that is the displacement current density. That two expression you should remember. While you are considering the conduction current, you should consider the Ohm's law. Okay. While you are considering the displacement current, you should consider the capacitance. Okay. So you have to remember all the notations. So while you are writing in the examination, you should write elaborately. If you are written the R, it should be equal to rho L by A. What is R? What is L? What is A? You have to write it elaborately. Right? Rho means that is the resistivity. L means the length of the conductor. A means area of the conductor. Likewise, here also the C is the capacitance, epsilon is the permittivity, area of the capacitance, distance between the plates. Okay, you have to write all the things. And also one more thing. So while you are writing the relationship, that is the V equal to E into L, you have to write it elaborately. Here the length is the L is the length of the conductor, E is the electric field. So we know the relationship between the electric potential in terms of electric field. V equal to E into L. Okay, if you are using L here, you can consider the length. Okay. Anyhow, both L and D. If you are consider the D, that is also the distance in meter. L also length in meter. Both are the numerical value. So here the notation only is different. Okay. You should remember these two things, that is the conduction current and displacement current. Through that you can apply, and you can, in the last case, you should remember the Stokes theorems here. Okay, that's a line integral, it should be equal to surface integral. Here it is directly converted. So that is the, from the Stokes theorem we written the expression, and you can compare the LHS side and RHS side, which is the common term you can eliminate. You see that these both are common term. The surface integral and ds, it is common term. These two expressions are equal. That is the Maxwell's equation. That is the Maxwell first equation. Okay, they may ask you Maxwell